Okay, well, welcome again, everybody. This is Spike2 Analysis 2, and I'm using version 10.09a, which is in development right now and should be out in the next few weeks. We started 10.09a because of a minor fault that I found in the program, but also that we had a request from one of our viewers, for a means of measuring level channel to give then a plot of the amount of the drug or liquid delivered through a syringe with a known fixed delivery rate. So look out for that in the near future. Okay, so let's get rid of the splash screen here. Before we go on to the result views, I'd like to talk a little bit more about the cursors, the active cursors, and real-world applications here. So on the right, as part of the same data file, you see that's channels window 1, channels window 2. I have blood pressure at the bottom. And above that, I've created various channels to ultimately end up with mean arterial pressure. Okay, now this could be produced on or offline. Above that, again, produced on or offline, there's a shortened version. I'll explain more about that in a second. So another mean arterial pressure, but a short step to get to this point. Okay, so what do we do? What did we do? First of all, I took cursor 0, and let's just put this in the center of the screen. Now remember that cursor 0 must move before any other cursors will update their positions. Okay, now I'm using control and dragging the x-axis so I can see exactly what the display will end up like. So cursor 0 set to active mode, and I'm looking for a trough find on the bottom channel. To get cursor 0 or any of the cursors, it's control then 0, 1, 2, 3, etc. up to 9. Now, cursor 0 is always in the file. It's just hidden or visible. The other cursors have to be added to the screen. Okay. Now, what I then set was an amplitude. So for the trough, I must find the lowest value, as it were, and then a rise away from it of 50 units. And that gives me successful trough detection. Now, if I just cancel out of that and step, control shift and step, you can see cursor 0 now finding the trough here, and it will find each and every trough after that. Now, I could have skipped a step with cursor 1, but I thought, no, I'll illustrate it longhand. And I asked cursor 1 then to go active mode and look for the trough behind cursor 0. So where cursor 0 had previously been. Now, what I mean by the possibility of removing cursor 1 is I can leave a data point behind when cursor 0 stepped to the trough position. So I can ask cursor 1 to go and find that data point that I place in the file. So I wouldn't have to go and search for a trough again. And then because I've bracketed this area, this cycle, then I've chosen cursor 2 to go and find not the peak, but the maximum value between those two cursors. Okay, there's no chance of failure, or I can't think of a way that technique would fail then, you see. Okay, so what do we then do? Well, to get the output, I first went to analysis and measurements, or through this quick button here, to data channel. And this allows me to create multiple channels, either to memory or to writing them to disk. And I've set up cursor 0 here already. It's taken much of its settings from the data file already. And I've asked for real mark output. And that gives me a trace like so. So in this case, I'm going to plot systolic value. So I'm just putting a label in there. I'm marking the data at cursor 0. So where cursor 0 is step 2 in the file versus on the y-axis, the value at point on cursor 2. So that's the highest value I found. Now, if I switch to the other channel, diastole, you'll see that this is taking its value from cursor 0's position, so the trough, and it's again plotting at cursor 0 time. So I've aligned the two measurements. Okay, this is a change from previous versions where we can have multiple measured channel measurements started off all in one go. Previously, you had to set up each channel in turn and process the file time and time again, that is, one after the other to get the same result. So the two outputs are here, okay, M1 and M1A, because this new method produces one channel, one memory channel of a real mark. So at each data point, there are values behind it. The first value in this case being the systolic value. The second data point or data value is the diastolic. So I have duplicated channel M1 as channel M1A, and using the channel draw mode, I've selected data index 1. Now, if I change that to data index 0, you'll see that it looks exactly the same now when optimized as the systolic, as it should. Okay, so there we go. Systolic and diastolic. Now, for some people using older versions, earlier versions, to go from this to the mean arterial pressure may mean creating two virtual channels. And these channels are created with the expression Rn, meaning real mark, the channel number, and then the length to span, I'll go into that later, and a code. So the last 0 there is the data value to use. So 0 for the systolic, 1 would be for the diastolic. Okay, so I've created the systolic channel. I've done the same for the diastolic there using 6002, which is the number we can see here on M1A as the source. And finally, to the map, which shows us channel 4001, that's the memory channel M1, plus 2 times channel 4002, which is the, sorry, I realize I made a mistake there. Should be the same channel but different data values. Oh, no, sorry, I'm talking out of turn. I'm taking the virtual channels here, 4001 and 4002. So systolic and diastolic as part of the formula to create the map channel. Now, if we see a shortened version of that, that's V4. So I could have not made these channels here and just created a single memory channel M1 systolic and diastolic combined, at which point I could use this Rn expression. So real mark 2001, so memory channel using code or marker data 0, and here again the same channel with marker code 01. Exactly, otherwise exactly the same equation. So some easy steps to get to mean arterial pressure. Now remember, this could be set up as part of your sampling configuration. Cursor 0 can be stepping, and we can see the output in near real time. Okay, just had a quick question which seems to be relevant. Can the maximum values of each pulse, i.e. cursor to maximum, be automatically sent to the log or a grid document? At this point, no, but if we have an XY view, it is a text document as well. So you could take, yes, let's just very quickly do that. An XY view, let's get something out of this. ECG 2, cursor 0, cursor 0. Let's just try that and process. Okay, so now easily enough, edit, copy as text, text document, and paste. Okay, so there should be our 2 columns there. Now, with a grid document, as you've already seen, it would be laid out a little more neatly. Now, if you really wanted those values printed to the screen, printed to a grid view, a text file, as the data is accumulated, then certainly I can write you a script to do just that. Okay, so please get in touch and we can go over any other details you want from the script. One question before that. I've answered that one, I think. How do you pull up cursor 0, which I answered as control and 0, 1, 2, 3, etc. That will bring them all up. Okay, right, so that was the blood pressure. Now I wanted to show you a couple of other data windows, data types. So EMG on the left and some of the problems we might face when using active cursors to measure it. So on the left here, I'm going to make this larger so we can see it more clearly. And the usual thing, I've created a duplicate of the lower channel and I've smoothed it. And occasionally there's a little blip before the main event over here. Now we may find that if we right click and produce a channel process for the lower channel and say median filter, add, we can remove some data like that if there's just 1 or 2 errant data points. Now I've got a very wide time constant there, okay? But that can be used for removing stimulus artifact, etc. So that's a possibility. But it looks as though we're stuck with the data as we have it. And that's going to cause a problem when we come to measure the duration of these bursts. This one I don't believe is a burst worth measuring. I'm using the horizontal cursor here as a level at which I wish to trigger the beginning of the waveform burst. Okay, so in this case, cursor 0 is set to active mode on the rectified and smoothed channel, and the threshold is H cursor 1. Now, if I do this, you'll see that if I move cursor 0, move it to the right using Control Shift and the right arrow, it latches what appears to be correctly on the rise there. If I move again, it stumbles over the small event. So how do we get around that? Well, if I right click on cursor 0 and set active mode, we say a delay after crossing of say 50 milliseconds, and try once again, it skipped this event because it didn't stay above the threshold level, horizontal cursor 1, for 50 or more milliseconds. Okay, so we can avoid small events like we see in this data with that technique. Now, if we then want to find the beginning of this change, I thought I might use slope percentage. So I'm looking backwards on the same channel from cursor 0, because that may be high up on this waveform, and I'm looking for a percentage of 5% of the slope, and that's good enough for me to indicate the beginning of the burst. Now, if I increase that, I haven't tried this, but let's increase that and try cursor 0 again. Yes, well, that's fairly close value, but you can see we do get a change as we get into this slightly less smooth section. Okay, so that's one way of finding the beginning of the burst. Now, the same techniques as used before, measure to channel or measure to XY view. We could ask for another cursor to step forward through this burst, again, possibly looking for to avoid data that drops underneath the threshold for a very short time and look for where the threshold or the waveform returns to threshold. Another way, of course, is to throw cursor 2 way to the right, if we can, and then ask it to walk to the left. Remember, we can do forward and backward searches through the data. And once, again, we have, as with many things in Spike2 and Signal, we've got multiple ways of doing this. So I could have created another channel, perhaps a slope, a differential channel, using the channel duplicate and then process, which I could use to help find the transitions or positions that I want in the burst. Okay, so that's hopefully given you an idea of how to set up cursors both for EMG and blood pressure. Right, another quick question. Can you check frequency in hertz? If so, how can that be possible? Can you elaborate on that, please? I'm not quite sure I follow you. So I'll come back to you as soon as I get a response. I'm going to close this data file down. I may come back to it a little later, depending on the questions. But now I have two windows. I have the original view on the left-hand side and then a duplicate which I've produced on the right-hand side. It's Friday evening, as it were. I want to shut this down and I want to come back on Monday morning and I want to bring up this data exactly as it was before, was on Friday. So if I close each window in turn, so close this window here, I haven't at that point saved a resource file. Okay, the resource file is only saved when the last window of that data file is shut down. To get around that, where you see close channels SMRX1 here, if I now press Control, File, you'll see that this is close all and link channels. Sorry, close all and link to the data file, which is called channels.smrx. So I'll close that. Both windows disappear. I'll go and open that file again, channels. Right, okay. That's because I had memory channels and virtuals, of course. So it's come back with as much information as it could retrieve. The memory channels have disappeared because, remember, they're in memory and are lost if we close the data file unless we save them back to disk-based channels. Okay, so let's get rid of these. Field potentials. We'll try some cursor positioning with this data here, which has markers 00 and 01 indicating the beginning and end of each segment of data. If I show you the whole file length, it's very, very short and probably imported from Signal. The markers here, beginning and end of the sections. I've asked cursor 0 to find data points on channel 17. Okay, so I'm looking for the stimulus mark, or in this case, the beginning of the data section, which happens to be the same time as the stimulus. So I'm going to cancel out of that a second and make it easier on myself by right-clicking on channel 17 and then using the marker filter. I'm then going to hide away the end markers. So the 01s are going to disappear. Update. Now, ideally, if we've got a long record and we're unsure of all the other markers that may be contained in there, it's better to switch off the 00, invert the selection, and then update. So you're guaranteed that there's no other markers included that may cause a problem. Right. If I move cursor 0 now, just zoom in a section, right. you'll see that these cursors don't seem to be falling into the right positions. In fact, we're getting marks like this, number 5 with an exclamation mark after it, saying that it had failed. It's true. Well, there are some problems with the setup here. Now, we've dealt with possible failures with cursor 0. It now will find every stimulus or beginning of every data section. So let's see what we need to do with cursor 1. Cursor 1, I've asked it to find the trough in the data. Okay, I'm sorry, I'm just going to move the window over a little bit more so we can see. Right, so cursor 1, active mode, trough find, on channel 1, all correct. Start search at cursor 0, finish at 8 milliseconds after cursor 0, where the trough, and this is the one that I'm after, has a rise away from it of at least 200. And we can quickly check that with Control and Alt, remember, to see what sort of amplitude, and we can drag left to form a rectangle to get amplitude and perhaps duration. So it's easily getting 200. So why is cursor 1 not finding the right peak? And that's probably because it's stumbling over this stimulus artifact, which could be positive in some of the sweeps and negative in the other. So we really need to start our search some short period after the stimulus artifact is finished. We'll say OK to that and click on cursor 0. Now cursor 1 has correctly found the trough. Because I've divided the data into effectively 3 now, there's from 0 to the trough at cursor 1, and there's from cursor 1 to the end of the data section, which we know to be approximately 4 or 5 milliseconds. Because of that, I've then asked cursor 2 to go active and not find a peak. Remember, that could be prone to detecting small inflections perhaps, or peaks that we don't really want to find. So I've gone for the easiest method, and that is a maximum again. And that's looking between cursor 0 and cursor 1. Well, what if the stimulus artifact was really, really large, in fact, larger than this peak here? Then I should really be adding again that little safety factor there with cursor 2. Cursor 3, maximum value again. I think for this data, it's clean enough. So from cursor 1, 4 milliseconds, find the maximum in that range. Now we could look here to find that turning point rather than the maximum value. I don't think I'm going to do that now because we haven't really got time, but another mode to find where we change sign. Okay, so if people are after that position there, it'll be turning point. As it is, I've chosen maximum. Going on from there, I've thrown in 2 other cursors. This is going to be quite important for quite a few of you. Repolarization percentage. I want to find out the slope between cursors 4 and 5. And so I've set my positions for a repolarization percentage on channel 1 as being 0% and cursor 1 as being 100% repol. Therefore, I've asked cursor 4 to go to 20%. And so it's found itself here, and cursor 5 to 80%. And it's found itself here. That now lends itself, or the way the cursors are set up now, lends itself to an XY plot to give us duration, that is to the trough. We could measure the slope between cursors 4 and 5. We could, using curve area, draw an imaginary 0 line between the intersect of cursor 2 and the intersect of cursor 3 to obtain an area in this, an area here. Okay, all to one XY view, or if you wish, to a data channel. Okay, well, I thought that would be a little more interesting to go through this data and seeing some of the problems you might face using active cursors. So I'll pop this guy away. I think I can save him there. Okay, now we'll go to the demo file. The idea here is to look at some of the result views built into the analysis menu. Okay, so let's have a look at a waveform average first. So we're going to process X channels. Okay, now we say channels these days. If you're using something like version 5 of Spike2, you could only process one channel at a time. These days, I could either select the channels that I wish to process, and they will now turn up in the list, or I could type the channel list that I want, so 1 to 99 inclusive. Now, with a waveform average, the channels would have to be at the same sample rates. If they're not, we would need to use a channel process to match them to the same rate. So imagine these two, well, they probably are different, these two channels. This one is at 10 kilohertz and this one at 100 hertz. Okay, so not a good combination there. But we could say to channel 7, channel process, and match to channel, add, and the channel we want to match to is channel 1, sine wave. And that's gone to 100 hertz now. There we go. But we've lost all the information. That was a very fast sine that I'd put in there. So not 100% convincing, but the channel is at 100 hertz, and that's going to allow us to average both of these. Not that I want to do that now, though. So new result view, waveform average, multiple channels. For all of the result views, we would set a width for the output. Now, in this case, I'm setting 0.1 seconds with half of that as the offset. We don't need an offset, that can be set to 0. I then choose a trigger for this average. Now, I'm choosing channel 2, which happens to mark each of the peaks throughout this record. And that's not to say we couldn't have just manual. Now, manual would mean that we could place a cursor on the data, or we could supply a time and say process, and we would get one sweep of output, one average from that time for 0.1 seconds. Okay, now we can show that happening in a little while as well. Most people, though, would use a trigger. Now, the next thing is aligning the data to the trigger. So we've got a separate stimulator, let's say, firing away under the control of a 1401 or independently. And because the data points, the sample data points of the waveform are not time locked to that event, that stimulus marker, then the event can occur like so, but your data points could bridge this, or they may just be in line. We just don't know what's what. So we need to do something about aligning the data. And in the past, we always used next data point. So we shift the data slightly to align to the next data point. We added then nearest data point. So data could be moved left or right to align. Following that, as computers became a little faster, then we allowed linear interpolation. So that's good. Takes longer to process than either of the first two, but it's not as good as cubic splining. So we're fitting a spline to the data, and that gives us the best accuracy. Right, so I can add error bars, and whether we want the sum or the mean of data. And importantly, for some people, keep item count for each point. Now, in this situation, it may be used because we have waveform data that fills the entire average width, and we have shorter sections which may not fill the entire average width. So you can imagine now we have, say, always data in the pre-trigger area. Therefore, we've got the same count for all of the bins in the result view. To the right, past 0, we may not have data in some sweeps. So we get a 0 count for that particular sweep. So the point is, the average could be filled with data sections of different lengths up to the maximum width that we have here. Right, so we're going to go new, and I can process in stages if I wish. Perhaps if I tile vertically, I can process from 0 to 30 seconds process, and then I can say from 60 to 120. Now, if I right click and show info, there's 191 sweeps already before the process, and now 389. As I'd asked for the error bars, there they are on the outside, and we're currently displaying the standard error of the mean. From the drawing mode, we can choose standard deviation, and we can choose 2 times standard error of the mean. Right, now the next step is to gate by events. Or no, I'm going to stop there just for a second. Let's say that we wanted to do exactly the same process of 0 to 30 seconds, but we wanted to clear out what we already have in the result view. One way of doing that is to go edit and clear. So the front number of sweeps is 0. I'm going to process the first 30 seconds again. We have the same 191 sweeps added to the result. If I now clear result data before process, I may have extracted this as text before I move on to the next area, which was something like 60 to 120 seconds. And instead of this accumulating to 300 or so sweeps, we'll see it at just 198. So the possibility of clearing out the result view before you go on and process another area, or adding different sections of the data file into the result view. Okay, you may be wondering what gated by events is. Okay, we're going to switch that on. We're going to clear, and we're just going to reset everything that we have here. Let's take 2 cursors and let's put them here. Let's back to cursor to active mode, just make that static, just in case it flies off trying to find features. Cursor 2, yes. Right. And here I'm going to place it in the middle of these 2 events. With gated by events, we used to have a process where we would find on another channel a gate, a marker, and we would then specify a time range around that marker through which we would look for triggers such as the peaks of this sinusoid to add to the result view. Now we've extended that gate so to allow fixed length, that is, find a gate here just like the old process and add in data from say half a second before it to 3 seconds after it, and then move to the next gate and use the same fixed parameters there. To a new type, which is variable length. So in this case, I'm just going to process one area, and that's going to be find the beginning gate and find the end gate, the green text mark that we see here, and the blue text mark to start. So variable length, the gate channel is number 4, the text mark. I can set a marker filter, so I could load in the code of the marker that we need. and it would ignore everything else for the start, and likewise for the end. Now, if I want to process everything inside the gate, that is from the blue to the green, I have no pre-gate offset and I have no post-gate offset. So gate end channel is number 4 and no marker filter again. So if I say OK to that, but now I specify processing between cursor 1 and cursor 2, process, we have 18 sweeps. If we look at the data view with cursor regions, the sum of the markers on channel 2 is 24. There we go. So there are 24 possible triggers in the time range I asked to process, but only 18 of them have been added to the result view because of that gate. Now, of course, that would increase if we edited the gate offset, say minus 0.5. I think that takes negative, and 0.5 afterwards. Is that enough time? Probably. So we'll get a few more markers in, and we're going to clear for process. There we go. Okay, so that's the idea there. Yeah, I think it wasn't, shouldn't have been negative. Right, that's it. Okay, and I'm thinking now just that the field potential and all these other windows that we've been dealing with have not really shown clearly what these cursors are meant to do. So I'm going to right click on cursor 0 and switch to set label. And from here, I go user defined. I can say stim. I can apply that change to 1. I can say that's also user defined. Trough, apply. We could change to peak. Let's go to 4, where we could say user defined, and we know that's 20% repol, pol. And to that we could also add, say, the channel value, channel 1 at the cursor, and apply. So you can see now, if I cancel out of that, there's the value, 471 at the intersection. If I drag it, it's getting smaller, and up here, larger. So the point is, you can set your own labels for these cursors. All of that information will be saved with the resource file. Okay, back to the result views. So you've got an appreciation of the average view. We should look at others now, which from our list are interval histogram, stimulus histogram, event histogram, phase histogram, so all event-based data. The stimulus histogram is a PSTH. We call it a stimulus histogram because there may not be negative time involved. Then down at the bottom here we have power spectrum, waveform correlation, and frequency histogram. Frequency is actually events as well. So correlation, power spectrum, and waveform average sitting in a group on their own for waveforms. Now, one thing that's missing here is, for some people, is coherence, and we do have a few scripts for that. There have been quite a few people asking for it just recently. So if coherence is your thing, then please get in touch and we can send you a few example scripts. And coherence uses power to obtain the result. Okay, let's see how these differ then. So something like a stimulus histogram, PSTH, we're going to go for. So a width here, 0.6 seconds, bin size, 0.3. So I'm choosing half the width for I'm choosing 0.1 seconds as our offset. out of 0.6 seconds total width, and I've got a 30 millisecond bin size. Now, I don't believe there's a limit to the bin size going smaller or larger there, but I stand to be corrected. So I'm processing channel 3, a response channel here, and I'm going to use the trigger, channel 2, and I'm going to add into it raster data. And I have no auxiliary channel. I'll explain auxiliaries in a few moments. New, and process the whole file in this case. As you can see, stimulus histogram. Ideally, we'd have no events at the time of stimuli. In this case, because the bin width is fairly broad, I'm getting a fairly low count of events. Following that, the bin's showing you the count of the number of spikes that fall within that bin, and above that, raster data showing us on a sweep by sweep basis the distribution of the events in each sweep. Okay, now let's just quit out of that for a second, and let's assume that, let's make a point that we feel that the third spike, the third event in our response channel is closely correlated to the stimulus time. Other events tend to move around, but we think that this third event tends to be time locked, or fairly well time locked. Well, how are we going to get that information out? Well, once again, we could use active cursors. So we have cursor 0 in active mode, and that's going to find the data points on the stimulus channel. So every stimulus marker there is. Cursor 1 is going to do the same thing, looking forward of cursor 0. So after the first stimulus mark, it's looking for the next one. So I've set a really big interval, big time range over which it's going to search. And I'm looking for one data point, so just the next. If I'd set this to a greater point count, we're going to skip that many data points before latching on a final position. Okay, now cursor 2, which I think I set to inactive, is now going to find data points between cursor 0 and 1 on the response channel, and I'm looking at a point count of 3. Okay, I could fill in the position if search fails here, but if I do, it validates the cursor. So if it still fails to find what you're after, according to the program, if the cursor is told to go to another position because of a failure, it is still valid, and we don't want that. And that will become clear in a second when we now quickly test our cursor. So cursor 1, the first marker here, cursor 2, the second marker, and I'm looking in channel 3 to find the third event. And in that period, there are not 3 events, but if we move up a little bit, there we go. So beginning, end, 1, 2, 3 markers. Next step then, let's produce a new data channel. And this is going to be, let's delete what we already have. This is going to be third mark. And I'm just going to call it an event type. And it's going to plot the time that cursor 2 finds a valid point. If cursor 2 doesn't find a marker, so if there is no third marker, no measurement is taken, no event is marked. New, and process the whole file. Okay, so now we should see there and there. So 1, 2, 3 in this segment, and 1, 2, 3 in this segment. That's the third marker. It's a little bit off topic there, but if I go back to settings, oops, wrong settings. If I go back to settings here, and now ask for M1 as the auxiliary channel, change, okay, and process, you may see some small markers here. It's difficult for me to see on this screen, actually, as well, because they are rather tiny. Anyway, the idea is I've marked in the raster plots the third event. I'm just going to change to a different auxiliary channel, and that's going to be our text mark there, because I found that this showed up a little clearer for us. Okay, and process. Right, close. Now, if I go and change the drawing mode of the raster to be a sort 1 draw, I'd hope to be able to see in here. No, I think let's go settings again, process settings. Let's go to 1 second, 0.1. Change, okay, process again. Yeah, so not really showing up well enough. There. Yes, I can't do any more with this. Right. If we've got those markers shown, and there is a relationship between the stimulus time and these markers, and these marks, the third mark in the train there, then we can redraw this data, and using the channel draw mode there, and on sort 1, we should start to see either an S-shaped curve or some form of fairly straight line indicating that, that there is this close relationship. Okay, we'll try that again in a short while, hoping that we can get a better result out of it. I know why. Let's just change it to 9, which it should have been. Change, okay, and process, close. Now we should start seeing something. Channel draw mode, sort 1, okay. All right, okay, you've defeated me. Let's change the process settings, 0.6 again. And not gated process, that's better. Okay, right, so much for practice. There should be a nice line of symbols indicating the position of each of those events, the third event. And I think the reason I'm not getting it is because I'm using a PSTH, and the critical point here is PSTHs exclude data that's previously been used. So the reason I'm not getting so many outputs is if we zoom an area like this, I would trigger on this first event here on channel 2, and I would get a sweep including this data and maybe some of the pre-trigger. But as we move to the next trigger, our sweep length may include data in the previous sweep. And therefore we say, no, we can't process that. So we'll move on to the next trigger. If that trigger is also within the sweep length, it'll also be excluded. So you've got to be a little careful with that. So let's now correct my mistake there by going to Analysis, New Result View, and this time an event correlation. So same channels, we're looking for the auxiliary channel there, New and Process. That's looking a lot better already. And right-click, channel draw mode. We move to the to sort 1, draw, and OK. And where are you? Where have you gone? Ah, there we go. Right, hidden down here. I hope you can see this line here of blue markers. So those are the times set in order from the closest to the trigger point all the way through to the longest duration over on the right here. Okay, sorry I can't increase the size of the symbols there, I should be able to. Right, there we have that. Let's just quickly see if there's anything here on the chat. So I think this one may have already been answered in the chat. So how can one export the values of the cursor analysis as performed for the population spike or the third marker event from a whole recording? Right. If you've produced an XY view, you can easily get it out as text. Okay, that's nice and simple. Edit copy as text, edit pull down copy as text will get that for you. If you're creating a measure to channel function, so yes, measure to channel, you could then use file and then let's click on the right window first, file and export as. And here we have options for text file and spreadsheet. Normally spreadsheet would be the one that you want. Text file, as I mentioned in the first of these sessions, is logical channel 1 with a header or not, its data points, followed by a small break, then channel 2, logical channel 2, and so on and so forth. So it is not a nice rectangular output, as you would expect it to be for taking to Excel, for example. So that's why we put in spreadsheet. And spreadsheet allows us to resample all of the data to a common factor and get this nice output. However, everybody's different. Everybody needs something slightly different. And so we could look at this output using a script to give you more information. Many people just recently have been asking about raster data. So I've written scripts to produce something a little like this, to dump the list of times relative to 0 for a section of the data file. I've used the result view like this just to set everything up for me, and I then grab the information through the script and put it out to a text file. Okay, I hope that helps you there. All right, I see that Marika has helped with that one. Right, there's Miguel. In an autocorrelogram, how to achieve that your y-axis contain the correlation index from -1 to 1, instead raster or count? I'm not quite sure. Let me have a think about that. If I don't come back to you in this session, I can certainly drop you an email and add the answer to the video when edited as well. Right, okay, there is a couple of other questions as well, but before we go and answer those, I think we should just get a little more idea of these other analysis techniques as well. So we've got power spectrum, which is something that seems to be coming up as a question. We've also got phase histogram. Okay, now all of these result views follow the same process in terms of setting up. This is the channel I want to analyze. A lot of the time you have a trigger channel as well. What is the width of your result view? And that could be time, that could be frequency, etc. So the dialogues change slightly, but they should have pretty much a common feel. In the case of a phase histogram, we're looking at the channel 3, the event channel here, the response. And let's say we have 360 bins. And let's have a maximum cycle of, say, 5 seconds. And the cycle marker is channel 2 here. Okay. We've done raster data. We've looked at auxiliaries. We did a forward auxiliary process before, but we could have been looking backwards as well. And we could have said all sweeps within the range, any that fail are excluded. Okay, so let's make sure we're not gated by events. We're just a straight phase histogram here from 0 to the end of this file process. Okay, so what this has done is set the start and end markers on the stimulus channel, say the peak here and the peak here as being beginning and end. And that's divided up by 360. Okay, so that's your total duration of the output. And then we've binned the corresponding events into the phase, correct phase within that 360 degrees. So you can imagine now a gate walking, and we have a cycle. The cycle changes in duration, and we would need to treat those cycles as 360 degrees now. Okay, so that's how a phase histogram works. Now, if we get on to power, where are we? Analysis, new result view, power spectrum. Again, multiple channels if we wish. I'll keep it simple. We're looking at channel 1 here, and we want the best resolution we can go for, which is 262,144 point FFT, which means that I need at least 262,144 data points for one measurement, one sweep, one result. And I simply don't have 2,621 seconds of data in this window, as this channel is sampled at 100 Hertz. So the realistic values I should be going for is something like 256, 512 maybe. Let's go to 256. That gives me a sweep length at a minimum time that I can process of 2.56 seconds. Okay, now we can then apply windows to the data, or no window, so Hanning, Hamming, geysers, so raised cosines, that sort of thing. I'm running out of time to describe all of that, but let's just stick with a usual Hanning or Hamming window and go new. Same again, processing from start to the end of the file, process, and there it is. Power spectra, which is the sum of all of the sweeps. We can right click and choose info and find out how many sweeps were included. Older versions of the program produced a result, a sweep, on one section of data, and then we moved along to the next section. Newer versions overlap the data, so we get more information back because of the windowing that would have lost data previously. Okay, so there it is. As with all of these views, we can switch to logarithmic displays. Okay, and all of these analysis procedures can be performed online as well. Now, I'm not sampling this data, but this is a good replica of data being captured. And if I go to settings, change, and now the process dialog has been modified. In manual mode, it works just as if we're offline. Gated by events, you've seen what that does. Automatic, though, is what we really need for this online process. And so I'm going to update the window as quickly as I can and I'm going to process all data or last data. So I know that I can get the smallest section is 2.56 seconds. I'll optimize the display after process, hit apply and OK. And as the sinusoid changes, you should see the frequencies in this power spectrum update. Okay, so we're getting slower and we should speed up again in just a second. So there we go, starting to speed up again. So this peak should start moving to the right. Now we don't, although I think it's a good idea that we have some sort of active cursor process within result views, we don't have it yet. So the best thing to do is to employ a script for that. But we're trying to convince the software guys a little more of an active cursor in a result view would be a good idea. That an active cursor in a result view would be a good idea. Okay, right. Question before was, can you show how to analyze frequency and power of LFP data, so wavelet spectrum FFT while sampling? Okay, I can't do the wavelet because I haven't written a script to do that. This means using a couple of new commands within the script to gather the data, perform the wavelet analysis, and build an image on the clipboard to then paste to the screen. Now, there's an awful lot of data to process often, and we've got 100 million data points that we could put into an array. This is a 2D array, and it's very easy to exceed that. So I'll have to think of a way that I can produce the right sort of output for you. But to do spectrum, I hope you've seen that already, looking at the sinusoid before. So that really is your FFT, a power spectrum. Okay, so can you tell me, Josephine, if that has answered your question, already seeing the power spectrum processing online? Don't forget that we have also, while rerunning or sampling, take this channel, analysis, virtual channels, create new, and we can put into the expression field here spectral functions. So this could be power in band or ratio of bands, spectral edge, mean frequency, dominant frequency. So let's choose something that we haven't used before. So mean frequency. We can limit the band range. There we go. So that now is the mean frequency of the waveform that we're collecting here. Okay. Yes, we could go further. I will mention again that active cursors, active horizontal cursors, could be used on this virtual channel because it's another form of waveform. Okay. Right. Colleen is asking, how can you regulate the number of plots in the power spectrum? Do you mean the number of sweeps taken? Sorry, I've missed the next part. I mean, for example, 20 thin plots instead of 3 large plots. 20 fine plots? Right, so you mean taking individual slices and seeing what the power is at that time, moving to the next time slot and doing another measurement? Yes. Okay, I'll give you a form of that. Often the devil's in the detail here, so let's stop the rerun. Okay, let's have cursor 0. No other cursors. Let's throw these other guys away. Cursor 0, I'm going to set it to active mode, and it's going to move by 2.56 seconds. Sorry, it's not data points, is it? It's going to be expression. That's cursor 0 plus 2.56 seconds. Okay, so whenever this cursor moves, it'll move by the width of the power spectra window, the FFT size that we've asked for. And now, setting it at 0, we could produce a new result view, power spectrum, channel 1, 256 point, new, and we're going to measure from cursor 0 to cursor 0 plus 2.56 seconds. And if we clear result view before process, there's one sweep. So that's the first sweep from 0 to 2.56 seconds. So as this cursor shifts on to 2.56 seconds, info here, that's one sweep included. I process again, but because clear result view, the result data before process is on, the number of sweeps is still 1. So I've replaced the old with the new. Now, some people have asked me to take this result as a waveform, paste it into a new channel in the data view, which I'm happy to do. So you'd get the same profile here drawn over the 2.56 seconds, and then again for the next sweep and the next. And of course, we could tell cursor 0 to step by half that, or a third, or 2/3 as the interval over which to calculate the new FFT. Okay, so I don't think I fully understand what you're asking, Colleen, but again, please get in touch, or if you want to expand on that now, great. Okay, I think we're a bit past time, so can I ask for any other questions here? Is there anything that's unclear, anything you'd like to go over again, or anything that you think that I should be covering? Okay, I'll give you a few seconds. I can't tell whether anybody's typing. All right. Okay. Good. Right. Well, I'm glad it's helped everyone. An hour is a very short time to get all this information across. Again, hopefully we've shown you what is there, what's available, and hopefully you'll go and investigate further yourself. Slight changes between version 10 and 9, etc., but fundamentally the dialogues remain pretty much the same. With older versions, as I mentioned, being able to process a single channel, maybe not as many as, maybe not multiple channels, I mean. Okay, when we get to at the end of all of these sessions, we'll be putting all of this together. So we'll have a complete experiment and we'll go through all the setup from start to end. Type of 1401, the sampling configuration we'll need, any outputs we'll need, through to sampling, online processing, and finally offline analysis, and hopefully export to publication quality. Okay, so what have we got next? We've got spike sorting next, I think, isn't it? Okay, so next week, the start of 2 spike sorting sessions. So we hope to see you then, and thank you very much again for coming along. Okay, I'll end the meeting now.